Good morning, everyone. If you are here for IPPM, you're in the right place. So thanks to everyone for being here, and welcome to IETF 116 to those people in the room, as well as, it's getting dark and mood lighting, as well as everyone who is remote. So we're going to get started now. We do have a pretty full agenda. So you want to advance the slides? Cool. All right. So if you've been at a IETF meeting before, you should be familiar with the note well. But if this is one of your first times, please do take the time to read this and familiarize yourself with the note well. This is the conditions under which you participate and contribute work within the IETF. If you want to read it in more detail, you can just use your favorite search engine and look up IETF note well. So as a reminder, we do have a masking policy for the meetings here at IETF 116. So if you're in the room in person, please do keep your mask on at all times. There's an exception for the person who is presenting at the mic. If they would like to take off their mask, they may. But otherwise, please leave your mask on for the whole duration. And we thank you for respecting everyone around you. All right. So we have a MeetEcho link. For the people who are remote, you can clearly use MeetEcho to join the queue. But for everyone else who is in person, we are also using the MeetEcho lightweight client to do the queuing. And so please pull that up and join the queue that way, as well as being in the mic line here. As far as sharing slides, we're able to share the preloaded slides here, but if you would like to drive them yourselves, you can also do that by requesting the document sharing icon, and we can grant that. And we do have a link for the notes and the notepad. I have also put that in the chat. So to that point, we will need a note taker for this session to just help us take notes. And generally that just consists of capturing the high level points, and particularly when people come up to the mic and have discussions, or are there any decisions that we make as a group, recording those in the notes. So could we get a volunteer to help with notes this time? We're going to need a note taker before we get the session started. So all right. Any volunteers? Could we get someone to just sit in the notepad and help take notes here for the discussion that we're having? It's a great way to be engaged in the conversation and keep track of what's going on.
And remember, you just have to keep the high level points. You don't have to transcribe everything. So it's really, really helpful for us if someone can take that.
Yes, thank you. Alex Clem, thank you. Much appreciated. All right, we can move on, and we'll monitor the chat and be able to relay a thing if we need to. Great. Okay, so as a overview for the agenda that we have today, we're first going to start by going over all of the current working group documents. We do have quite a few that are in progress at various stages. So we'll get an update on all of those and see which ones are have open questions and are ready to progress. And then after we get through those, we do have a set of lightning talks. These are just quick one-slide proposals for new work. So in order to get through all of those, we would ask that as you're doing the lightning talks that we keep these to be relatively brief so we can give time to everyone who requested a slot. Okay, and I think that is it for us. Actually, there's one other item that we want to highlight that is going to be interesting to people in this room. So later in the week, at the TSV area meeting, which is the meeting where we have just kind of the overview of the entire transport area, of which IPPM is one of the working groups. Marcus, my co-chair, will be giving a talk just on the status of IPPM and all the different types of things it works on to share with the entire community. So, since you're here, you people in this room are the experts. And so we'd love if you could join us at TSV area to help provide background. If there are questions that people have, you can help answer those. So please come out to that if you have a chance.
And that's on Tuesday, session 3. So please come there if you have time.
Great.
All right.
Okay, with that, let's get started. So I think up first, we're going to talk about encrypted PDM v2. Nalini, do you want to drive this remotely?
Hello? Can you hear me?
We can.
Okay. Yeah, no, okay. No, why don't you guys drive and
Sounds good.
let me see if I can put my thing on. I look terrible. Sorry. Okay. Yeah, so I got COVID. Tommaso will be there to, let me turn on my video. I can't, it's terrible. Oh no, oops, wrong one. Let's just go quickly through it, and Tommaso will be there to answer a lot of questions. So next slide, please. I'll go through it kind of quick. Okay. So what we've done basically is we've done we've made it kind of a modification that really simplifies things. So let's take a checkpoint. These are the fields that we've got in PDM v2. And so let's go to the next slide. And out of those slides, what we're doing is encryption and decryption. There's only one field that needs to be decrypted by the other end, and that's packet sequence number last received, or actually packets. It's packets. What happens is that the receiver takes packet sequence number this packet and sticks it into packet sequence number last received of his. If you didn't need to decrypt that field, then there'd be no need for have any kind of key agreement between the sender and receiver whatsoever. And all you have to do is encrypt. Now let me stop here and see if that makes sense to you guys of what I'm saying, because that's critical. Yes? Okay, so no questions? All right, grand. Okay, so let's go forward. So what we're doing, this is kind of as I say, it's a major simplification and restructuring, but I think this is really going to make things, work for the long term. So what we're proposing is we pass that PSNTP, the packet sequence number of this packet in the clear, and you don't ever need to decrypt that for the other side because it's in the clear, and he just sticks that into his last received field, and he knows what it is because it's clear. And then that also becomes the nonce that's needed for encryption. In the AEAD cipher suite that we're using, you need to have a nonce, and so why not just use PSNTP, because that works out real well. And we've added just one little field, an epoch field, for the rollover. And Tommaso can explain that if you want. So all the data analysis is done offline. And we'll just, because, clearly you're sending this data, but you need to figure out what has happened and do the performance matching and see, because really the point of PDM is to say this much time was sent in the network, this much time was sent in the server, and all that stuff can be done offline. And it greatly greatly simplifies everything that is in and the work of PDMV2, and also a lot of the stuff about the topology of having a primary server, a primary client, and all this carrying on. We had done that because of the key exchange mechanisms that were needed, and you only need to do key exchange if you're ever going to decrypt. If you're never going to decrypt, you don't actually need to know what the key is. And so, as I say, it hugely simplifies everything, and also creates a fast mechanism that I think we can implement. But we wanted to talk it over with the group before going ahead and making such a huge change, because it's really a large change. It's a change for the better, but it's a big change. So, yeah, let's see what the next slide is. But other than that, I think, yeah, that's what we've got. This is the current layout, and then we've just changed the new layout to have the PSNTP in the clear, and everything else is encrypted. Yeah, next slide. Other than that, any questions? Yeah, what do you guys think? Mm-hmm.
Just a quick question, if we could go back to the last slide. So, at which point here is the encryption boundary essentially, or?
Oh, yeah. Okay. So, yes, very good point. At global pointer, PSNTP and reserved are sent in the clear. Everything after global pointer is encrypted, but that's what's in that is the clear text that would be there. But on the wire, it's encrypted. Yeah.
Right. So, so what we're looking at here is the layout before encryption, and you essentially are rearranging things so you can expose the PSNTP and have everything after the global pointer encrypted. Okay.
Yeah. But as I say, the biggest thing of this is that if you don't need to have key agreement, you know what I mean? If you don't need to do if you don't need to agree on the keys, I mean, as you can well imagine, it's a huge simplification of everything. And I don't think we need to agree on keys. It's because, the other thing we were getting into is, as we're doing the implementation, it was getting to be a nightmare. Just trying to, the complexity of the code was getting to be a nightmare too. Yeah.
Understood. Great. So, I mean, it sounds like we want feedback or input from the group here. Do people have more questions, reactions to this approach? Even just expressions of, yep, I understand this. This sounds reasonable. I don't know if you want to comment any more in the room, Tommaso.
Hi, Tommaso Pecorella here. Just one thing, if you don't have a question now, but you might have in 10 minutes or half an hour, just come to me. We can discuss about it afterward. If something comes to your mind, we need inputs. We think that this layout simplifies a lot, doesn't actually impair the security of the system. But of course, as Nalini said, it's a huge change. So before pushing the new version of the draft, we would like to have an input. If nobody have an input, we consider it as a green light. Thank you.
And maybe, just since no one else is coming up to the line, but please. Oh, actually, Al's up there. Great. Please go ahead.
Well, thanks for the presentation, Nalini. I seem to remember that you have a fairly complicated key management scheme. And does this mean that you, with this new approach, you won't have to use that key management methodology that I think you had some help with some researchers and so forth who basically helped design it with you? Thanks.
Yeah, no, Al, you've hit the nail on the head. It was yeah, because a lot of that topology business was so that yeah, essentially we were having to do a key management, PK, to transfer keys securely, and then all that kind of business, and all that is not, and you only need to do that if the other end needs to know the key to decrypt. If you don't need to do that, then all that stuff can be done out of band. And in another thing, I mean, sure. I mean, of course, in order to analyze the data, you need to figure all that out. But yes, it usually reduces the complexity of all that key management business. And then, Tommy, if you can go to like one or two slides down. Yeah, go one more. Because I put in something for offline decryption. Because I mean, it's one, you do want to have the data analyzed at some point, obviously, but that can be done out of band and in in whatever methodology you like. If you want to have a complex topology, you can certainly do that. If you want to have a simple topology, you can certainly do that. But yeah, huge simplification.
Cool. That makes sense. I definitely think that the approach of being able to avoid the key distribution and key agreement will make things simpler. Just trying to push on this to make sure that we do believe this is the right approach, and of course, we'll have sector and other types of review on this. But what information could you get from this packet sequence number being exposed in the clear? Like, what is, I assume, based on this proposal that it, we think it's innocuous, but if you were to look at this in the, most devil's advocate way of like, this is potentially a problem, what would the concern be about exposing that? Or is there really none that we can think of?
No, I totally hear you. It's like it is exposing a field, that's put out there. But actually, the nonce is out there too. You know what I mean? I mean, you need one field that is that's exposed. And Tommaso, I don't know if you want to talk to this a little bit too. Tommaso is our cryptographer, and maybe talk to this. Yeah.
Yeah. Do you want me to speak on this microphone or that one?
Whichever you prefer.
It's okay. But I don't like actually to give my back to the
Please.
group.
Please.
It's just very nice. As Nalini said, we don't think that there is a lot of more issue with respect to the previous one. Meaning, as Nalini said, we had announced already that unfortunately have to be unclear. No way to avoid it.
That's the nature of
now. Yeah. Now we do have another field that acts as a nonce. It is a legal information, potentially yes. But I could say that there is a lot of other leakage of information from TCP, UDP, and other levels. Probably if you need that kind of obscurity, you will not need PDMVQ. You will need something that is fully tunneled, an IP over IP or IP over VPN and so on. If you want to put PDMVQ in the inner of a VPN, well, yeah. Information-wise, again, I don't think it's a big issue.
Got it. Just looking at the current document, where is the nonce currently? What field is used as the nonce?
It's in the PDMV2. There is a field. I think it says something like random. It's not in that packet layout. It's essentially
it's the random number. I see.
Yeah.
Okay.
It was a random number that was nonce. of course, with the caveats, because you can't, it's a random, but you can't repeat it, but whatever. It was the random number in previous one. We get rid of that and just use PSN instead.
Is this sequence number, the PSN TP, is that also going to be unique?
Yeah.
Is there? Can it be used as the nonce? Like, can we compress those such that we don't have a separate nonce, that we just use a sequence number as the nonce? So that is a technique that's been done in other protocols.
I think that yes, we can.
Yeah, that's the idea. That's what we're going to do, is use the PSNTP as the nonce. Yeah.
And no longer have a separate random number, but just, yeah, okay. I think then that sounds like an elegant solution as well.
No. Thank you. No more questions? Thank you.
Mm-hmm. Hey, so guys, let's just go real quick to the very last slide. I have to say this. So we're starting to see PDM in the wild, and they're not doing it correctly. This happens to resolve to one of the big telcos in India, and I am now being the protocol police because they're not crafting it correctly. But anyway, I had to do this. Okay, thank you guys so much. We'll go to SecDear and ask their opinion. Is that what you guys think we should do?
Well, let's revise the document, send it out to the mailing list, and then we can, if there are no comments on that, then we can send it to SecDear.
Perfect. We'll do that. Thank you guys so much.
Thank you, Newly, and I hope you feel better soon.
Yeah, thank you.
All right. Al, you are next up.
Do you want us to drive the slides, or do you want to share yourself, Al?
I think it's probably okay if you guys drive. Are you doing driving?
Sorry.
Hey, Greg, it's my turn.
You'll get your turn next, Greg.
Yeah. Okay. Thank goodness for video. Lets me tell a little joke to get started. So anyway, here's our talk. This is about the protocol for the capacity measurement that we've been doing. We added new security features, and we did that early enough that Marcus and Tommy were able to secure us another security directorate review, another early review. So we've actually got a lot to talk about. And Len Chaffetone and I, my partner in crime, have been working on this this draft. So let's get right into it. Next slide, please, Tommy. All right. So we promised to get the draft in great shape right after the meeting in November, and we succeeded in doing that. 04 was published in December. We retained the two authentication modes, one which handled the control packets, and the other that handled the feedback status packets. So we can add that on separately because there is some processing cost. And of course, we got the unauthenticated mode. So then we added a new mode for protocol-supported encryption of all the control and the status packets. Again, no load packets. And so we call this a partial encryption. And we chose an algorithm for that, so on and so forth. And we've also got an option that we talk about for users to make measurements within an encrypted tunnel. And they get to choose that. And that's a fully encrypted operation. So it includes the load packets and all the rest of the packets. So with that set of options, I think we've got a pretty good coverage for anything anybody would want. And so then, since we published the draft early, we started to expand looking at what the protocol can do. And we're finding this to be a pretty capable protocol. So not only are we doing our RFC 9097 maximum IP layer capacity measurements, but we're also measuring latency with and without the maximum IP layer load. And that gives us a range of the delays and delay variations that you would see in, an unloaded and fully loaded operation. We've always been measuring round trip time and delay variation. So it's really just an opportunity now to add some additional metrics, if we talk about that a bit. Another big feature that we developed in cooperation with ITUT Study Group 12 is there's a new recommendation on application traffic stream generation. And what you can basically do with this new recommendation is that there are templates for various applications that would produce delays and loss, and which are very interactive applications like e-gaming, remote drone control, video conferencing, and cloud rendered gaming as examples. And this new recommendation takes the measurements from the packet stream and calculates an interactivity factor. So we've basically shown that we can do this using our capability to do the different search algorithms. We basically replace the search algorithm with a traffic stream template, and we've done that very successfully. So that's a big win for us. A lot of people are interested in the delays of the customer applications, not just the fully loaded and the unloaded delays. So also we've got the ability to generate the broadband forums quality of experience delivered traffic stream, and we'll provide the selected computations to go along with that. But this stream generation will be available probably 2 weeks or so. Okay, so those are the things we've been doing since the last meeting. Next slide, please, Tony. All right, so I mentioned we got our second early sector review from Brian Weiss. Got that a couple weeks ago. Thanks very much, Brian, if you're in your shot. The key comments that I've summarized here are Brian basically saying that our choice of AES GCM with a long-lived symmetrical key is not safe, and he suggested a CBC mode. So we chose this because it's an authenticated encryption. It does both, and we think that simplifies the operation for our measurement system. But we can use AES CCM instead, get the same benefit. That's a counter mode with CBC MAC for authentication. So with that, we'll keep our initialization vector in the clear. We'll have to check the padding, if any padding's needed for any of our PDUs and the block sizes. We'll specify the IV generation. And one thing that I forgot to mention in the reply to Brian is that we'll be using the OpenSSL library to help us find the specs we need for interoperability for the encryption algorithm. So we'll test that out and see if we need anything else. But I think that's our way forward for the new encryption algorithm. Hoping to get some feedback on that. Okay. Next slide there, please. So some of Brian's other responses indicate the kind of tension that we've got between, the full force security, and measurement operations. In section 5.1.1, we didn't say that we use network addresses in the authentication digest. Brian says good practice to do that, but we basically can't do it. And that transversal is critical to our application here. It's critical to ISP subscribers, and precludes the addresses. So that leaves us open for basically that a valid message can be extracted and put in a different packet. That's called the substitution attack. Well, all the IPPM protocols are susceptible to that attack. In fact, it never even came up in OWAMP or TWAMP or STAMP, as far as I know. So we've got time in the digest. That's a partial mitigation, not full, but I think that's the best we can do with it. And the bottom line is, you got to make measurements accurately here. That's our primary goal. So, we're going to have to take some lumps in the attack space. So there's packet deduplication in DTLS and IPsec. That's seen as a feature, and that's fine for network encryption. But measurement systems want to observe packet duplication if it occurs. So again, we're at odds, and we've basically got to stay away from those two methods. That's a point I've made before, but it came up in Brian's comments too. So we've got that answer here again as well. Okay, so then next slide, please. All right, I'll cover this quickly. Brian pointed out that we got to make sure we've got solid, exact digest coverage. It's usually almost all the PDU fields. I really thought I defined MPC, but apparently not, so we'll fix that. We need to have the phrase support for client-server authentication, because we're going to retain the unauthenticated mode. So it's really it's not a requirement, it's a requirement for support, and that's what we'll do. So we've got the 4 security modes, but the tunnel mode will just be a paragraph option that we talk about, and one spelling thing there. So those are quick. On to the next. So next steps, we're looking for the SecAD feedback and sector interactions. Want to be sure we're still on track with this AES CCM mode, and our desire to use the long-lived keys. Assuming we get through that and update the draft fairly quickly, we could have maybe a last call in mid-2023. We plan to share more of our measurements on the list and move this work and other work toward conclusion by sharing measurements. And in our next major release of the UDPST protocol, that's what we call it, we're adding single client tests with multiple flows. That's real interesting to anybody who's doing active queue management or L4S, or anybody who's interested in supporting multiple servers simultaneously for capacity management, and also adding resilience to server failure. So this multi-flow, multi-server resilience is the big feature in the next major release, but there are 5 or 6 other things we're adding there as well. I mentioned the QED compliance stream. So a lot of work going on in this project. We've got 16 members now working on it with us. We're adding new members all the time. 3 new ones this year, and contact me to join up and help us out. Thanks. Any questions? I'll be glad to take them now.
All right, do we have any comments, questions? Al, one quick, I guess, comment I have regarding the kind of the substitution attack. I agree that trying to solve that is contrary to the nature of the protocol. Is that something that you would plan to call out in the security considerations, to just mention like, hey, this can happen, and just explain the nature of it and why there isn't a defense against that?
Yeah, I saw you nodding in agreement, Tommy, during the presentation. Yeah, that's what Brian's asked us to do. So we're going to go ahead and do that, of course. Yeah, the best thing to do is be upfront about these things. At least it'll be clear this time that somebody called out the substitution attack. And if anybody's got a great idea how to deal with it, Len and I are all ears. Yeah, me neither, Tommy.
All right.
Okay. All right. That's it. This is just backup. Thanks, everybody. I think I
Thanks,
kept
Al.
it to time.
Yep, we're doing well on time. We're 2 minutes ahead. We're rolling into time. And next up, Greg, for real this time.
For 2 ones.
Yes.
1 for 2. Okay. Hi. So first, update on on our work on precision availability metrics. Please, next slide. Okay, so to remind, what we're trying to create is the metric set of metrics that can be useful of, among other purposes, assessing conformance of the service to the conditions in service level agreement when there are multiple service level indicators characterized through their service level objectives. And what we believe is that though an operator and a subscriber will have them expressed for the subscriber, then operator might be interested in having their own threshold set for the internal to detect the performance degradation before crossing this threshold that a subscriber is paying for, so that they can take proactive, or at least to have a time for the review of a condition and possibly take corrective actions to avoid their breaking their SLO and thus SLA. So here in this figure, you can see that that's why we suggest that SLO might have a range. So the range, which is this space between their operational threshold and service threshold. Again, it's not necessarily the case, but at least that's something that we envision and would like to have your feedback on that. In terms of what we're trying, what these metrics are intended to capture is that not only periods when their parameters SLO is out of threshold, you see that as a red, but when it's in the service, when it's green, so that you see that red is matters, but so when there's a service compliant matters too. And that's what proposed solution or proposed paradigm tries to capture. So when the service is available and when it's not available. It's two states. Next slide, please. So what we have dated, we addressed the comments that we received during the working group adoption poll, and we very much appreciative of all the comments and suggestions and the discussion we had. We introduced the violated packet count, severely violated packet count. That is a step towards their statistical metrics. Also, we worked through future items. We had a future items section, and we reviewed one of their terminology that we'll get later, and some editorial needs. Next slide, please. So violated packet counter and severely violated packet counter, that to keep statistics of packets that crossed their SLO threshold. So that might be useful in statistical metrics to verify and reflect on compliance with their SLOs if they expressed for statistics. Next slide, please. We had, among authors, discussion about the use of precision availability metrics policy in a document. And we agreed that policy is not that well developed, defined term, and many people have different interpretation what it is. So what we agreed is that actually how we use this term originally in the document is and is envision of configuration parameters. It's something that is controllable and that can be set that and then affect how availability and unavailability crossing the violation or non-violation or severe violation can be viewed in a process of in a lifetime of the service. So thus we updated our document and replaced PAM policy with the PAM configuration settings to make it more direct and more specific. Any questions? Okay, next slide, please. So we always welcome your comments. Okay, yes, of course. Discussion items. So we reviewed the discussion items, and as you see, we address some of them in this document, in particular with introduction of violated packet counters and severe violated packet counters as the step towards the statistical PAM metrics. But we think that the document is reasonable in its scope, so other work items are other points of interest, topics of interest that have been identified and mentioned in our previous discussions. They deserve their own documents. So in the benefit of the progress, we point that they are out of scope of the document, but because they are of interest and they seem to be useful for the development of the whole paradigm, then they need to be worked on as a separate documents. Any questions? Thank you. And now we can go to the last slide. So again, as always, we welcome you. I appreciate your comments, suggestions, and we would like to ask chairs and the group to consider working group last call. Thank you.
All right, thank you. Could we get a sense in the room, or I guess on Meetecho as well, of how many people have read the most recent version of the document here? Got 1, 2. I'm glad for Greg. 3. So yeah, not a ton right now. So I mean, we always can garner more reviews with the last call, but I'd also appreciate if people could, take a look at the document and give more comments. It's still one of our, relatively newer documents in the pipeline, so we probably won't start it immediately, but I think it would be good if people can just take an eye and review the document before we go further.
Okay,
Thank you.
sure. Thank you. And I guess I'm standing here for the next one. Or I can go.
I think we're gonna go to the
Okay.
on-lag ones next, and we'll come to the Sampiang at the end. If that's fine. Thanks, Greg. All right, gentlemen.
Hello, everyone. I'm Tianran from Huawei, and this topic is about performance measurement on lag. And next, please. As we are going to request for the working group last call, so I would like to recap the solution briefly. Firstly, the motivation. In the lag scenario, as we know, the link delay of each lag member link varies. So lag will introduce jitter for time-sensitive traffic. So in some case, we need to explicitly steer the traffic across member links. That requires a solution to measure the performance metrics of every member link of a lag. However, existing active PIM cannot do this. So we propose the idea similar as the BFD on lag. Next. And here's the solution overview. We extend OWAMP, TWAMP, and STAMP. And we build multiple micro-sessions between two endpoints. The extensions include the new command types to indicate the set of micro-sessions of a lag and correlate the test packet to a particular micro-session and carry the member link information for validity check. Next. This is the OWAMP and the TWAMP extension. For the control message, we add two commands, the request OWAMP microsessions and the request TWAMP microsessions. And for the test packets in unauthenticated mode, we add the sender microsession ID and the reflector microsession ID in both sender and reflector packets. Next. And for the test packet in authenticated mode, we do the same thing. Next. The stamp extension is much more simpler. We just add a microsession ID TLV, including the sender microsession ID and the reflector microsession ID. And next. There's a discussion in the mailing list. The stamp support both stateful and stateless mode. So should the PM on lag also consider both modes? So we add the following clarification in our text. Firstly, the micro stamp test support both stateless and stateful modes. However, the micro stamp test does not introduce any additional state to stamp. That means any procedure with regard to the micro session ID is stateless. Next. So for the next step, we think the authors think the draft is ready for a working group last call, and of course, more comments are welcome.
All right. Do we have any comments, thoughts, questions? Minako are in the room. All right, we're kind of sleepy today, everyone. I guess on this document again, same as for the last one. How many people have or these documents? How many people have been reading and keeping up on these? Okay, so more. I think we have 5 hands in the room, so that's good to see. Okay. All right, yeah. So we'll kind of get it in the queue.
Oh, thank you.
All right.
Hello, can you hear me?
Hello, we can hear you.
Perfect. So hello everyone. I'm giving an update on our latest version of the responsiveness under working conditions IETF draft. Next slide, please. So this is a pretty major update. We did quite a lot of changes. I've been very active on the GitHub where everything is happening these days. The major changes in this draft are primarily, well, on the first hand, we did an entirely revised algorithm where we completely changed the way we are generating the load and also how we are measuring the responsiveness on during the duration of the test. Secondly, we changed the way, or we added a way to discover through DNS the availability of a service endpoint that allows, based on a host menu, based on an organization, you can now find out whether this organization is hosting a responsiveness measurement endpoint. And finally, we also added the .well-known URL for the configuration file so that it's easy once you have this host name that is the responsiveness measurement endpoint. So now you can easily, based on the host name, you know that you can then use the .well-known URL to fetch the configuration file, which will then bootstrap the responsiveness test. Next slide. So the revised algorithm, what has changed? Previously, we had quite some logic around when to add or not add additional connections to the test. Now, as we are generating the load, we are just simply adding one load generating connection per interval. And in the draft, we recommend that the interval should be 1 second. So it means during the duration of the test, we are adding one load generating load generating connection per second. Then the stability detection. What we do now is we take the last 4 intervals. Of course, this is also configurable. What we choose the last 4 intervals, and for the detection of the capacity saturation, and we compute the standard deviation of the last 4 intervals and make sure it's within 5% of the moving average. That way, we have for us, it seems to be much more stable and much more easy to and much more reliable to detect stability. And additionally, also, one of the major changes is as we are generating load on the network, we first try to reach stability for the capacity, which means we continue adding connections to the pool of load generating connections until we reach this capacity stability. And then we start measuring for the responsiveness, because it's only once you actually fully utilize the pipe of the network, you will actually be able to measure the buffer load on the network. So only after we reach capacity stability, we start measuring responsiveness. And so we start probing, and then we probe until we reach stability in the responsiveness probes as well. The responsiveness computation also is now using 95th percentile trimmed mean of the last 4 intervals, which is also has shown to be much more accurate, because we are now generating a very large number of probes. So we have up to 300 different probes during the duration of the test. And so we feel comfortable of taking a trimmed mean over the 95th percentile here to compute the responsiveness. Now, next slide, to visualize this a little bit more on how this is happening.
Yeah. Christoph, I just wanted to check. I do see that Greg joined the queue. Greg, did you want to just have a clarifying question here?
Please.
Thank you. It's easier when it's tried. So I understand you use 95 percentile. Do you see a value of making the percentile threshold of something which can be defined for different situations?
Yes.
So it might be, for example, 99 or even 99.9. So depending on their condition interest of operator.
Yes, absolutely. So in the draft, we try to be a little bit more clear there, in the sense that we now list out the different variables or parameters that one can tune when measuring responsiveness, and the 95th percentile is definitely one of them as well. It is, from our experience, having a 1 second interval, using the last 4 intervals for the stability detection, the 5 percentile, the 5% for the standard deviation, and the 95th percentile for the trimmed mean has shown to us that to give fairly good results. It is very risky if one changes these parameters, is that things may not converge, right? If, for example, you choose the interval too long, or for example, you are aiming for a standard deviation that is too low, you may never converge, because some networks may have high variance, and so they may not converge within the time that is configured.
Okay, yeah, very good, thank you. So definitely something valuable information in operational considerations. But thanks for your answer.
Yeah, I agree that that's something that we should kind of write down there. Is there concrete guidance we can give to explain how you would know that you've chosen parameters that will not converge? And relatedly, how do we know that these parameters would converge on all network environments?
That's a good question. I don't think there's a way you can actually say, okay, these parameters are never going to converge, or these parameters will always converge, because yeah.
We also don't have to solve it right now, but if we think we can, writing that in the document would be very useful.
Yeah, I think that's a good point. Yeah.
So we have Al in the queue. Do you have more questions on this topic, or?
Yeah, just a quick question. Thanks, Christoph, for putting this stuff forward again. How long does it take to run a test now in sequential mode? Thank
you. Yeah, I'm still under 30 seconds in sequential mode. So we do download first, we saturate the capacity, and then saturate the responsiveness, and then we do the same for the uplink, and we are under 30 seconds.
So there are certain kinds of channels that aren't going to give you stable performance for 30 seconds, right? It's just something to think about. Thank you.
Meaning over 30 seconds, it may have too much variance.
You'll see the capacity vary, and
Of course,
and that
yeah,
the latency under load will vary as well.
yes.
I'm mostly thinking about mobile channels, of course.
Yeah. Yes, I agree on that. We with the goal of this being to provide a fairly quick test and a quick number, we basically choose to accept this kind of a variance and these inaccuracies. It is still a temporal measurement, meaning if I measure it today, I get a certain number. If I measure it tomorrow, I may get a different number.
Game we all play here, but the problem is making assumptions at the beginning of the test that may no longer be true because you've tested too long, taken too long to reach the conclusion. That's the
Interesting.
Yeah, that's the risk. But anyway, just something to think about.
Thank you. Yeah, I'll give this a thought. We can move on maybe to the next slide, unless I don't see the queue here, so I don't know. So I want to just visualize the algorithm a little bit, just to make clear again on how we are. If you have these intervals here, shown here as the vertical lines where we continuously are adding connections. On the top graph, you see how the good put is continuously increasing over time until we reach the maximum capacity that is available on the path between the client and the server. At that point, when we reach the maximum capacity, then we have the buffer occupancy that starts to increase because now we start creating buffer bloat on the bottleneck link. And so again, this buffer bloat also has a maximum. Here in this example, we chose a fairly extreme example of 64 megabytes worth of buffer bloat. And now as we keep on saturating the link and continue to add connections even beyond reaching the capacity maximum, we are actually now able to fully utilize the link and fully fill the buffer of the buffer bloat of the bottleneck. And so we can fully measure now the responsiveness under working conditions by continuing beyond just detecting capacity stability, but also responsiveness stability. Eventually, the responsiveness then flattens out, and that's when we declare saturation and can then provide the final number. Next slide. So much about the revised algorithm. One additional change is the DNS-based service discovery. So we have the service type _nq.tcp. And so now if somebody, for example, an organization, for example, ops.cr is hosting a test server, one can then do a DNS lookup for the PTR record and then can request the SRV record, and then we will be able to get the host name rpm.obs.cr, which will then be hosting the RPM test server. Now, based on that host name, one can then use the .well-known URL to fetch the JSON config, which will then provide the URLs for the large, small, and the upload endpoints. And so based on this, for example, any organization could simply host this kind of a test server and expose it to the public and let it be discovered through DNS. And that brings me to the next slide, which is basically what are our next steps. From our point of view, this is fairly, in terms of technical content, fairly complete now. There's some cleanup done. I would like to see if there's a need to review or restructure the algorithm description to make sure that people can actually understand it, and that people can implement something based on the description. There are currently now 3 implementations of this. There's 2 open source and 1 closed source, that's the Apple one, and 2 open source implementations. So we believe that this IETF draft is fairly good to go and maybe ready to move towards the next steps.
All right, thank you. Do we have other questions, comments on this? Do you have a couple more minutes? Al, go for it.
Yeah, Christoph, a quick code-related question. I can't run Ventura on my MacBook. It's still fast as hell, but it's too old. So is it possible to get the code and compile it, and will it still work on pre-Ventura OS?
I would love to, but I cannot share the code with you. However, there's the open source tool that is based on Golang. That is exactly the same It's basically the implementation of this algorithm in the Golang programming language, and so you can just simply download this one and run it on your MacBook.
Yeah, I did that last time, and if you remember the measurements, there was a vast difference between the Mac native code and the Go responsiveness results, especially in terms of the capacity measurement. So look, you made the suggestion. I'll check it out, but
Yeah.
I think our friend Will might have some more work to do.
Yeah, I mean, we are very actively working on the Go implementation as well. So if you have any problems or bugs that you find, we'll all be very happy to fix them. Unless there are more comments or questions.
So just a question or comment here from me, from Marcus.
Sure.
It's actually for both Al and for you. It's like in Al's presentation, we saw that he's measuring capacity, but he has a method of measuring some kind of responsiveness, and you are primarily measuring responsiveness here, but you're measuring capacity. I'm wondering if you guys need to discuss and maybe produce something on when it makes sense to use which of these methods, because we might be shipping documents trying to solve very similar problems at a kind of similar time here. So I think some discussion on this. I'm not sure if it should go into this or that document or a separate informational document, but I think it's something we should discuss.
Yeah. So Marcus, the answer is, let me jump in here, Christoph. The answer is really simple. The proposal that Christoph and his team have put together is basically all TCP based. And with the IP layer capacity measurement, we're using UDP datagrams. Now, in a lot of networks today, TCP and UDP get the same treatment. Sometimes they get different treatment, but we're taking very different transport layer approaches to the measurement problem. So there's a real gap out there among the tools that are widely available. Most of them use TCP. That's why we're really pushing hard to get people to adopt our UDP-based methods as well. As we know, Quick is going to eat the internet, and that's UDP-based. So let's recognize the future and the fact that UDP is a big part of it. Thanks. Please add your thoughts, Christoph.
Yeah, I think the fundamental difference is the layer at which we measure. So our goal on our side is to use, it's not about TCP, it's about using HTTP actually. And whether that's HTTP2 or HTTP3, meaning quick, is basically the same. We are not advocating that it must be HTTP2. So from our perspective, we want to use the protocols that are used by the end user for their data transfers, and that today is HTTP. And while capacity measurement at the IP or UDP layer is a different point of view, a different approach, where it's more about maximum capacity. While for us, it's more about, if, for example, if those HTTP flows end up using a congestion control that is very sensitive to loss, then they may measure a very low capacity, even if the real capacity is actually much higher. So it's in my opinion, those are entirely different goals and different backgrounds.
But you're still trying to maximize capacity, which most customer applications don't do. In fact, with Quick, we won't even know if they've chosen a congestion control that's sensitive to loss or whatever. I mean, I think most people are trying to avoid that now, but these are different approaches to the problem. But I think that the bottom line is, at least for us, and this is another big difference, by the way, we're trying to measure the network contribution to responsiveness, and we're trying to avoid getting that mixed up with the host stack and the host processing. So that's another big difference. I've heard stewards say that when this is the responsiveness is going to tell you when your network gets sluggish, but it's more than that. It's the end hosts, and that's both on the user and the server side. So we're distinguishing this, and I see Tommy nodding furiously, so I'll stop. Thank you.
Yeah, I'm in violent agreement. I think maybe one thing just for the notes or the minutes here that we could capture is we should have something, not necessarily directly in the documents addressing the other one on how it's different, but really clarifying the scope, the end-to-end nature versus the focused nature, the application layer protocols versus the UDP and IP measurement, and potentially even as far as to influence the titles of the document. So it's very clear, I think, as we are sending things up to the IESG, etc., being very precise in just the title of, like, oh, this is, capacity for UDP packets on this network versus end-to-end application level responsiveness over IP networks. Something potentially more verbose, but that leaves no room for ambiguity here.
Sounds good, Tommy. Thanks.
Yeah.
Okay, let's move on. I think next up we are going to talk about some data integrity for IOAM.
Hi, everyone. So this is an update on the draft about integrity of in-situ OAM data fields. Next slide. About the status, so we just published a version 3 right after the IETF in London, which mainly includes some edit changes and also a fix to the INS section that was required for the early allocation, which, by the way, was approved. And we also have some, and we also have some pending modification for our next release that we will publish right after this IETF.
The main change is about a quick fix on the integrity algorithm. And the good news is that we received the NAC, not so fast. We received the NAC from the implementer, finally. And yeah, this is still at the early stage from result point of view, but it looks quite promising.
Can we clarify the meaning of an ACK here? Like,
so the implementation is finished.
Okay, good.
And we received some very early results. But I mean, from the implementation point of view, it looks good. And
okay.
For performances, we are still waiting more results.
Okay, I think that's better than just an ACK.
Yeah,
We have a right close. You know, we have a proper fin and success on.
Next slide, please. So let's have a summary of the draft to have something different from previous presentations. So you can consider the following rule to know how it works. An IOM node would only sign data fields it writes, and data fields modified by other IOM nodes are excluded from the signature, obviously. Next slide. So for the edge-to-edge option type, this is quite straightforward. The encapsulating node would sign its data field, and the decapsulating node would check the signature of the encapsulating node. So here it's easy because there are no transit node involved. So it means only checking one signature, the one of the encapsulating node. And this is a little bit similar for the proof option type, proof of transit, sorry, type 0. Here the encapsulating node would sign its data field as well, but here the cumulative field would be excluded because it's going to be modified on the path. And the decapsulating node would check the signature of the encapsulating node. Why? Because transit node would only modify the cumulative node, the cumulative field. And as I mentioned, this field is excluded from the signature. Next slide. So the tricky part is about the trace option type, either the pre-allocated or on the incremental. They share the same option type header. Here, the encapsulating node would sign its data field, and so would each transit node. So at the end, the decapsulating node would check the signature, the whole signature chain, right? From last transit node signature to back to the encapsulating node. Next slide. So I think we should put that discussion back on the table. If I recall well, this was with you, Tommy. So we opted with the working group to go that way, which was to exclude the integrity protection of the header. But I think it would be worth discussing it maybe to have header protection, because if you think about it, if you have the integrity protection of the data fields, but someone modifies the namespace ID, for instance, which is a common field shared by all the option type headers, then the integrity protection doesn't make sense anymore, right? And so we could discuss maybe having only the namespace ID also included in the signature, or just have the headers. So I would propose this one, for instance. If we consider the same rule, now we would have an IOM node only signs what it writes, so something more generic. And now not data fields anymore, but fields modified by other IOM nodes are excluded from the signature. Next slide. So that would be the example of fields that would be included from the headers. So here for the trace option type, we would include the namespace ID, the node length. We could also include some flags. So the first one, bit 0, is the overflow flag, which doesn't make sense to include because it might be changed on the path. Bit 1 and 2 are for the active and loopback flags. And I think that it's important to have them signed because you don't want those flags to be changed on the path, right? And obviously the IOM trace type would be included as well. And for the proof of transit, we would have the namespace ID and proof option type, but not the flags because they are non-defined yet. And the edge-to-edge, you would have all the header basically.
When we were saying that we would cover the flags in the trace option type header,
Yeah.
Are you proposing that you would only define it for those 2 flags that have been allocated so far, and that what is the extensibility story? Because another flag can be allocated, right?
Yeah. So basically right now, the overflow is excluded because it can be changed, and the last one is excluded because it's not defined yet. So we might say something like future flags allocated might require a change to the IOM integrity. So
I see. So
but I mean, by default, you have to exclude them from the signature if they are not defined yet.
right, but then essentially we add a requirement such that if you ever do, it's almost like you would want to have this document then update the IANA registry for the flags to include a field that says yes or no, is this included in integrity checks?
Yeah, correct. Next slide. So we want feedback from the working group about that. Should we go that way and have header protection back, actually, because we already discussed that previously. And if we go that way, we might also consider to put back the support for the direct export option type, which might mean updating the RFC, but anyway.
Do we have any opinions in the room on Mideco, etc.?
I mean, the question is, should we keep it that way without header, or should we only include the namespace ID, or should we include all the header like I proposed? So 3 solutions, actually.
Can you refresh my memory on why we chose not to do the header before? Was it just simplicity?
Yeah, basically, yeah. But in fact, we exclude some fields from the data field, so it doesn't make sense actually to exclude the header. It's not more complicated.
Right, and we would do it consistently such that you would always include these particular header fields. Yeah.
So basically, that would add more to the signature for the encapsulating node, and so that would allow the encapsulating node to check the header at the end, which is not a big burden.
But yeah, that sounds reasonable to me, especially if it's based on now, having a bit more experience with it. Yeah.
Okay. So I guess we go that way for next revision. Yeah. Okay. Thank you very much.
All right. I think next up, we're going to get into some Yang, starting with IOM Yang. Sorry, Craig.
Okay. Hello again, and Tianran again. This topic is the Yang data model for IOM. Next, nice. We received the comments on a working group last call before IETF116, and I listed these questions here. I'm not going to read all of them, but the authors suggested to narrow down the scope to RFC 91, 97, so that we can resolve all these questions. We proposed this and discussed this in IETF115. Next. So in the latest version, we removed the IOM DAX and the 2 IOM flags to align with the RFC 91, 97, and add max length constraint to both pre-allocated and incremental tracing. And we add examples in the appendix, and we corrected editorial notes found by Tom Patch. Thank you. And next. After that, we got many new requests from Alex Huang and Thomas Graf and Greg Muskie for the IOM DAX option, because they think it's useful and could quite potentially be used. So what's next? My suggestion is to move this draft forward as it is now, and we start a new dedicated draft for IOM DAX with interested people, because IOM DAX configuration model and the usage are quite different from other IOM options. That's why there are so many questions in the front page. In this way, I think we can focus on IOM DAX with a dedicated draft. Yeah, that's all. Any comments?
Greg, you're in the queue.
Yes, thank you for the discussion that we had on the mailing list. And I just saw the comment from Thomas on the mailing list to this subject. I'm still not really sure what you mean that IAM DAX is different, because even though it's related to how the operational state and telemetry information being transported, but that is not really something that Yang data model controls. Yang data model controls the profile of whether the node supports IAM and what operational state and telemetry information it's capable of supporting. And to me, that is consistent across all trace options, whether it's incremental, whether it's pre-allocated, or IAM DAX. Yes, I agree that flags are very different, and we should yet to see how flags being applicable to different data planes. But there is a lot of interest, particularly in IAM DAX, in MPLS network actions. So having this actually being part of this IAM Yang data model document, I think that will expedite things and will help experts in routing area that are working on M&A. So I'm not really sure what you mean by IAM DAX is different from base IAM RFC.
Okay, thank you. And could you go to the first page? Yeah, this one. Actually, this is the question you raised during the last call in IETF before IETF116. I think there are several points we need to consider. Firstly, the second bulletin, whether IOM DAX is an integral part of IOM, because IOM DAX definition is different. At least the definition, the IOM DAX definition is different from IOM definition. And second, IOM DAX need to configure the maybe the match part, the flow selection, and also you need to configure the filter. You need to configure the export like that on every node, including the transit node. But the IOM tracing, you just need to configure it at the ingress node.
If I may, so I don't see that transport of information should be considered as a part of IAM Yang data model. So again, I want to repeat my point. 197 and IAM DAX RFCs, they define how we identify their operational state and telemetry information that we're interested on generating. Okay, so yes, 9197 defines the mechanism to collect and transport this information, but it does not change the definition on how this information being identified. It's consistent across whether it's IAM base or IAM DAX. We use the same register, we identify this informational entities in the same way. So it's the same for all these trace modes. So thus I don't see, and again, I agree with you. how the information is collected and what the, we can call it management plane out of band, whether it's gRPC, BroBuff, Kafka, it's operational. It is not part of the IAM Yang data model. That's, at least that's what I think. Probably somebody else will have a different opinion, and we should have this discussion on the mailing list. But again, I don't see that the principal difference between these two RFCs. And I'm really wonder what you see as a definition. You see as a difference between the definition of 9197 base, where we can refer as an IAM base specification, and IAM DEX, because both are using the same method of identifying information that needs expected or requested from a node. A node might not necessarily provide this information, but that's an intent, an interest that is expressed by encapsulating node, and it's expressed regardless of the method how the information to be collected and transported, whether it's in a packet or it's for the management plane.
Yeah, I know, and I cannot give you the answer right here, but I can copy the definition from the RFC 9197 and the definition from IAM DEX, and give you that definition. We can compare in the mailing list.
Okay, I think it's, for the sake of time, let's move it to the mailing list. Thank you.
Hello, Thomas Graf from Swisscom. So many thanks, Tianran. I replied you on the mailing list, and just 2 comments. I would focus on the abstract describing that actually the Yang model is focusing on configuration only, and I concur with Greg. Basically, it would be great that we can keep IAM DEX in the Yang model. That would be great and helpful for the operator. And I suggest, since the IAM DEX in the security consideration sections refers specifically to configuration that you should actually filter down, I would recommend mentioning that in your draft document, that this can be applied by the filter configuration. That would be all.
Okay, it depends, and I think to me, both way, the split draft or one integral draft works for me. Both works for me. So yeah, if you decide to include IAM DEX, I can bring it back, and yeah, maybe I need your help, and we can work together to make it better.
Sure.
Thank you.
Yeah, and just as a comment, as chair here, we did run a last call for this before, and we got the feedback, and the feedback is what we're hearing in the room today, that people want to see DEX covered as part of this. I think some of the comments I see in the last slide of let's just finish this one up. I think the quickest way to finish this one up probably is to have it include the full scope. Trying to get consensus around not including DEX and then having a new document, which we then have to get consensus to adopt. That's just a lot of overhead. And I think, we have this work. Let's just, make it contain the full scope of what it needs to have to be useful. And I think that's actually the most efficient way to go forward here.
Okay, no problem. Thank you.
It's Greg for real this time.
Thank you.
Okay, so this is an update on STAMP Yang data model work. Next slide, please. So what we've done is we updated lists, a session sender, a session reflector, configuration, operational state. There are definitions for the stamp session ID on session sender. and they turned reportable statistics to read-only, and some nits again. Never short of them. So this session test sender test session, and thanks to Fooder for their great discussion and thought-provoking comments. So as you know, in STAMP extensions, we introduced STAMP session identifier, and it's very useful from implementation point of view. So that's it's because it's a sender unique, and that helps to reduce their parameters that to be used for STAMP session demultiplexing. But at the same time, and that's related to the next update that is related to how STAMP session ID presented at their sender. So it might not necessarily be known. So it's not really useful for key in configuration, because as you will see, it can be auto-generated by a sender, not provisioned. So in that regard, we are rolling back our previous change and going back to the full tuple using IP and UDP port numbers for the sender and the reflector. Again, just to make you aware, and if you have comments now, let's hear comments now. Otherwise, I would appreciate the comments on the mailing list. Here.
Footer with Nokia. Hey, just a question about the diff serve code point value. Is that pulled out of the TLV or out of the diff serve code point I receive in the header? Because that header value can change throughout the network.
Yes. And that's something that we'll need to think about it, because that is a point that we might say that it will be any. So basically, we'll make it a union of the value or any.
Perfect.
But yes, it's, you'll see that in the last slide, I said we might be, we'll definitely need at least one more version. Thank you. Next. So similar for the reflector test session, even more so because yes, it might be provisioned for the specific session sender ID if session sender is provisioned. But if session sender is auto-generating this STAMP session ID, that operator system would not know it. So there is no really logical reason to have it as a configuration parameter, a key in a list. So we are going back again to the parameters that are provisioned. Okay, next slide, please. And now the fun part with the STAMP session ID. So I already told you that for the sender, it might be either explicitly provisioned or it could be auto-generated. So thus we turned it into the union. So, and our reflector test session, again, it could be provisioned that reflector is explicitly told you, okay, so this is for this session ID, because if you provision on a session, it might be useful in simplification to do it similar for the reflector. Or say you take any. And test session state, it's just a number because it's known, it's reportable, it's read-only. Again, welcome your comments and thoughts about it. Next slide, please. So, closing next steps. We believe that we address comments, and we welcome more comments, and I expect at least one more version before we'll be ready for a working group last call. Thank you.
Thank you. I don't see any other questions or comments, so I think it's time now to move on to our lightning talks. So I think first we have the transit measurement option. Is this Tall?
Yeah, can you hear me?
Tall, go for it. Yep, we can hear you.
Great. So this is a relatively new draft which introduces the transit measurement option. Next slide, please. So we introduce a new IPv6 option called the transit measurement option, and the idea is that an ingress node incorporates this option into an IPv6 packet, and then transit nodes along the path can update the content of this option, which records information about their performance. And specifically, there are two main fields here. One is called the accumulated delay field, which is updated by each transit node along the path with its own transit delay, so that at the end of the path, we have the sum of the transit delays. And the other important field is the bitmap, which is kind of a congestion state bitmap. So each node updates its own bit in that bitmap, which represents the ECN state. So if according to the ECN state, the node is congested or the queue is congested, the bit is set. If it's not congested, the bit is not set. So this is a very short IPv6 option. It has a fixed length, and even though it has a fixed length, it gives a pretty good picture of the congestion status along the path. So we believe that it's kind of a complementary capability to hop-by-hop measurement techniques like IOAM. So for example, if you use IOAM, it has a relatively long overhead, but if you use the transit measurement option more frequently, it has a very low overhead. It can be used for detecting a performance issue or a congestion. And then once you detect that congestion issue, you can trigger something like IOM, which gives you a much more fine-grained measurement, allows you to pinpoint exactly where the problem is and get more information about that. So this is a new option and relatively new draft, and we would welcome any comments, any feedback about this.
All right. Thank you. If you have comments, questions, please bring it to the list.
Thank you.
And next up, we have Altmark Yang from Xiaoming.
Hi.
Please go ahead.
Hello, everyone. It's Xiaoming. Yeah, it's Xiaoming speaking. This presentation is on a Yang data model for alternative marking method. This is the second time this draft is presented. Next slide, please. This slide demonstrates main updates from version 00 to 02. The former has been presented at IETF115. Firstly, Massimo Nino was added as a new co-author. Welcome, Massimo. Secondly, in the latest 02 revision, cleanup on this draft has been done. By the cleanup, 76 errors and 8 warnings were cleared away. And now it's 0 error and 0 warning. Thirdly, some key references were added. One category is basic principle for alternative marking, including IVC 9341 and IVC 9342. Another category is data plane for alternative marking, including IVC 9343 and the MPL's in-band PM working group jobs. Note that the current Yang model mainly targets at MPL's data plane. They also would like to improve this model. In the next revisions, making it applicable to both MPLS and IPv6. Next slide, please. Next steps, the authors would like to ask for more review and comments. We'll revise this draft to improve it, and then we'll ask for working group adoption. That's all. Thank you.
All right, thank you. And next, I think we have some app quality metrics requirements.
All right. Hello, everyone. My name is Björn Teigen, and the purpose of this draft is to point out as clearly as possible that different stakeholders have different needs from a measurement tool and the metrics associated with that, and then to list a set of requirements that make it possible to address all of those needs simultaneously. So the three main properties that we've identified are capturing the information necessary to compute the probability of meeting network requirements, and metrics should be composable, to the point to the discussion earlier about measuring at the end-to-end on the application layer versus measuring further down in the protocol stack. If your metrics are composable, it's possible to reason about which parts contribute what to the total sum. And then finally, be applicable in both testing and monitoring for operators and applications and users. So if a metric or measurement framework can be used not only for sort of running a test at a specific time, but also for continuous monitoring, then we can address a wider set of needs. So if you read Gödel-Escherbach, we want the framework to be useful from multiple perspectives. Okay, thank you. And I'm also speaker for the next one.
Yeah. Here's the next slide deck.
Yeah, I wasn't sure to include both slides in one or not, so. All right. Yeah, so this other draft is our attempt, initial attempt at providing a framework that meets all those requirements at the same time. And this proposal, it's a structure for network quality measurements and a structure for defining network requirements. And the main idea is this property of defining what we mean by perfection, where if the network becomes better than that, it's better than perfect, and we can be sure that the network is not the cause of any performance issues at the app layer. And then another point, which is sort of the point of uselessness, where if the network is worse than that, then it's worse than useless, and we don't care about how much worse than useless it is. It's just this application has no chance of working well over this network. And then the idea is to specify a range between these 2 points, where sort of closer to perfection is better, obviously, but that we can sort of quantify where we are on that spectrum between perfect and useless. So that's the main idea. The version of the metric and the framework that we've specified in the draft is based on the QED framework from the Bourbon Forum. It's an initial attempt, and we would really like to work with the community to find the best solution for this problem. So appreciate any feedback, or if you want to work on this kind of problem, please talk to me. All right.
Thank you. All right. Next up, I think we are going to talk about the postcard-based telemetry from Hawaii.
Good morning, everyone. This is Hao Yu Song from Future Technologies. Today, I'm going to give a quick recap of the PBDM and the latest progress of it. So first, we give it a technology classification for PBDM. In this figure, you can see actually for the on-pass flow telemetry technologies, we have a family of existing technologies. Among them, the passport mode technology has been standardized as an IOM trace option in RFC 9197. And for the postcard-based technologies, we have two different options. One is instruction-based. We basically use the instruction header. That one is standardized as IOM DX direct export in RFC 9326. So it clearly shows that the marking-based PBDM, which is described in this draft, is a standalone and independent technologies. And it has a unique feature or properties that it has a near zero overhead. We just need a single bit worth of information to trigger the telemetry data collection at each node on the packet path. So the data can be collected by another postcard packet sent to some collector. So because of its simplicity, it has seen its application in a different network scenario. For example, it's already adopted in SRv6 OEM in RFC 9259. It's specified as an O flag to trigger the telemetry data collection. And in another draft, we also propose to adopt it in the MPLS network action as a flag-based action. So only use a single bit to trigger the data collection. But because of this near zero overhead feature, it also introduced several unique challenges that need to be solved. That's the common ground need to be covered by this document. Once we have this document, then which means all these issues can be covered here and can be shared by all the other documents which apply this technology. So they only need to specify where they will find this trigger bit. Then all the other issues can be find a solution here. For example, on the right side, we list actually 5 group of unique issues faced by this technology we want to cover in this document. First one is for the flow path discovery, because we need to do a reactive way to tell the node on the path what data we want to collect. We don't want to first need to configure all the nodes in network. So we need to do that reactively. And also, it's a much more challenging than the IOM DX to correlate the postcards collected from the every node on the path. For example, we must to tell which side of postcards belong to the same packet and in the exactly same order they collected. So it's very important to correlate them. We need to find solutions for this, and also how to configure the control plane to tell the node what data we want to collect and how we will export the result to the collectors. So that's a data export method. And finally, the important issue we want to cover is security considerations, because like other IOM mode, this also has some security implications we want to also cover in this document. So therefore, this is actually a very important document. I think it serves as a basis for all the other solutions which can utilize this technology. So therefore, we want to work this in the IPPM working group, and so request the working group adoption for it. Thank you very much.
All right, thank you. Next, I think we're going to talk about the DEX timestamp. Okay. And just know we have 5 minutes left, so we may not get through everything. We are going to close right at 11:30. I think it's actually, you have one.
Yeah. I only have one slide covering the 3 next draft actually. So yeah, thanks. So what we are trying to do is, I am Alex from INSA and I am presenting these 2 new extensions drafts to IUM. What we are trying to do is to aggregate the on-path delay that is defined in the draft presented and already adopted in OPS AWG, which is the delay between the encapsulation node and the transit node and decapsulation node. What we are trying to do is aggregate this directly by the node itself so that we can not also from performance perspective, but also from the correlation perspective, so that we can have the delay in IPFix. And to have that, we are extending the IUM direct export header to add the timestamp reference within this draft. And next slide, please. And with the second draft, by definition, IUM direct export uses a bit field to say to the node which metrics are exported. So that's why we also, for consistency, are adding, requesting this bit to allow the export of the on-path delay. The authors are aware that there are already approaches to compute this delay without these extensions. But what we are trying to do is aggregating already in the different nodes with IPFix, and also correlating this data. So that's why we are extending this approach to do this. So yeah, we would like to request more feedback from the IPPM working group through the mailing list, through our mails, or maybe in person. We are here the whole week of the IETF, so feel free to reach out and discuss with us why this is needed and this is important for us. So thanks.
Thank you very much. All right, and I think we just have one last from Giuseppe. Perfect.
Hello, can you hear me?
We can.
Okay. Yeah, next. I just will go through this single slide. So, yeah, you know that the alternate marking methods are already published as RFC, as standard documents, but there are few pending points to explore, considering that there are in some protocol no additional bit that can be used. Also, in some deployments, the entropy of the flow mon ID can be also considered, and in the end, also the multi-point measurement is something to take into account. This draft aims to consider all these aspects and generalize the data fields for all the transport protocols. So it aims to add some extended data to the based, let's say, data fields that is defined in the RFC 9343. So the scope of this extension is to have shortest marking periods, to allow more dense delay measurement, to increase the entropy of the flow monitoring identifier, to automatically set up the backward direction, and so on. So there are different extensions that can be done. So I welcome more feedback from IPPM, also because this kind of extension is also discussed in spring in some way. So we hope to have more feedback from from this group to also to share with spring working group as well. So that's all. Thank you.
Thank you. And we're kind of right on time.
Okay.
Perfect. Thank you. All right. Thanks, everyone, so much. I think that's a very productive meeting. Got some good discussions on next steps for how we can move forward on our different documents. So thank you so much. And again, please do come to the TSV area meeting tomorrow. You can hear Marcus share what we're doing here with the whole community, and please help chime in there as well. Anything else you want to say?
No, I think you covered it. But yeah, just repeating that, and it would be great because if there are discussions there about what we do in IPPM, what the future of IPPM should be, it's really good that we have the experts there. So please try to make room for that.
Thanks, everyone. I will see you around. Oh yes, my charger. That's a very good thing to have. Thank you.